I'm here with Juha Erkkilä from Opinis, and he will explore the challenges of creating a secure cross-platform exam systems using the free software. Please.
Thank you. Okay, so I think I skipped already a slide. There. I'm Juha Erkkilä from Finland, and I'm talking about implementing digital examinations in free software systems. I have been a free software hobbyist about 25 years now, and I love BSD Unix, but I've worked professionally with Linux about 16 years now. And I'm one of the main developers of the Puavo project, which is a free software project by Opinsys. Opinsys is a Finnish education technology company. And I'll give a very short introduction to Puavo, which is not the main topic of the talk. So Puavo is an operating system based on Debian, but it's also software for managing a large number of computers, and it's developed for school use, used especially in Finland and also in Germany, licensed on the GPL version 2+, and it's a company developed. I'm hoping that someday there could be a community behind it. If you want to know more, there's puavo.org and our GitHub pages. So now that you know what Puavo is, I'm going to move to a different topic, which is digital examinations in Finland. And the final examinations for Finnish upper secondary schools have been digital for some years now, fully for about 5 years now, and there's the Matriculation Examination Board, which is responsible for administering these examinations. And they decide the technologies used in these examinations, and these choices affect the technologies chosen in schools. The environment is called Abiti, and commonly the same system that is used for the final examinations is also used for normal course examinations. And laptops may be owned by schools or they may be owned by students. And once they get to an exam, they are booted from a USB drive to separate exam operating system, which is based on Debian. And that OS connects to a server that manages the exam sessions. The security requirements in these examinations are quite strict. For example, mice with programmable macros are banned because those could be used to contain exam answers. Problems include such as changing network SSIDs, which cannot leak into the computer desktop. And also basically anything smart and wireless is forbidden. So why use Linux for USB drives for exams? As the USB drive is distributed right before the examination, the OS security on the main hard drive is irrelevant, and the OS security in the exam is fully controlled, which means that the same laptops can be used for normal schoolwork and also for the examinations. So why not to do this? Well, one problem is that laptops need to support Linux fairly well. And in Finland, for about 10 years now, if you go to a computer shop, you may find a sticker on the laptop like that. It basically means that the computer is certified as an exam compatible, which basically means Linux support. But the other problem is that managing USB drives for course examinations during school year can be a hassle. And the USB drives are not as reliable as ordinary hard drives because the USB ports may gather dust during use. So some other problems that schools want to choose computer hardware freely. MacBooks do not work because it's a different architecture these days. Chromebooks have these OS verification features that make it really difficult to boot a USB drive containing Linux. And also many recent Windows laptops have issues. And here's a picture from the report by Matriculation Examination Board where they see that this is the future of Linux support with devices. So back in 2013, iPads were the only type of device that could not be used for examinations, but nobody wants to do examinations with a pad anyway. But then came Chromebooks, which many people liked in schools, but those could not be used. And then there were MacBooks. Already Intel-based MacBooks had problems, and it's worse these days. And the future may also see Windows-only laptops. So a decision was made that the USB drives will not be used in the future for the exam environment, and this will be replaced by a cross-platform examination application, which is going to support Windows, macOS, Chromebooks, not Linux explicitly, and this was a decision not opposed by many. So what is an examination application? It's an application for taking an exam, and it should lock the student out of their normal programs and files during the exam session so that they cannot cheat. So they cannot cheat, but once they cheat anyway, there should be a mechanism how to get them caught. So we should actually monitor student actions on their computer during the examination session. And after the exam has finished, the computer should operate normally. Now, how to implement this is an application. Well, this looks like something that the operating system should provide some kind of features for this. What do the competition have? Windows has something like take a test, which this is from Microsoft pages, Microsoft web pages. That take a test is an application that locks down a device and displays an online assessment web page. Okay, what does Apple have? Mac OS has an assessment mode, and I've understood that if you're developing this kind of application, one can get a certificate that unlocks some features from the operating system that locks the system down in such a way that only one application can be used. And this sounds better than the Windows solution because this is not limited to a web page. And Chromebooks, if those are centrally managed, they can be set up through a kiosk mode so that they disable certain features during the session. What about examination mode under Linux? The question, what are we actually doing here? During the examination session, the computer should be controlled by those who are operating the exam and not the student. But the same computer is to be used normally outside the exam. Well, the USB drive scheme, which is now nearing its end, this neatly solves this problem. Normally, the computer works normally, but when it's booted from the USB, it's controlled by the examination overloads. And there are some safety implications to user on that setting, but that's mostly acceptable because the USB drives come from a trusted source, so it's not a significant issue. The ideal situation would be to use two sets of computers, one for the examinations and one for the normal schoolwork. But the problem here is economics and convenience. It's nice for students to use the same computers that they take at home for the examinations. Now, the point of free software is to put users in control. And if users can manage the OS, they can subvert these requirements needed by the examination application. So it logically follows that systems must be managed by schools or some other organization, and users must not have full control. Implementing this requires two things. One is system security, and the other is the examination mode in itself. Now, about system security, when I was young, it was commonly accepted wisdom that having physical access to a computer implied full system access. But that does not have to be the case anymore. And for the exam mode to be secure against students, and we consider now students the hackers that we must protect against, the BIOS must be secured, boot process must be secured, system integrity must be secured, and we must deny them root access. What about BIOS? How to protect the BIOS? We must set the admin password so that students cannot access the BIOS. We could import an organization key to BIOS for secure boot and remove the Microsoft key if we don't need Windows support. Then the secure boot, which in itself doesn't mean much. In most Linux distributions, secure boot can be enabled, but because the RAM disk is not verified, it means that it's mostly for compatibility only, and it doesn't provide a real security. This is from SecureBot or Debian wiki, that SecureBot is also not meant to lock users out of controlling their OS systems. Okay, but we need that exactly that. So plan is to use, and these are plans, upcoming plans in the Puovo OS to support these kind of features. To use SecureBot, we should use a signed kernel, signed RAM disk, which is signed key with a key accepted by the BIOS. TPM is something that we can use for system integrity. We can keep secret keys in the TPM chip, unlocked only when booting into a particular environment with our kernel. And then we could use disk encryption, which is good for home directories, but in case the whole system doesn't need encryption or confidentiality, so we could use DM Verity or DM Integrity, where basically the data is written with a secret key, and it means that if some evil cracker boots the system with a USB drive with another operating system, he can try to modify the system, but it will be recognized as corrupt by the actual system. And we should prevent users from getting root, which is unfortunate because we still have a policy of giving them root on computers which are managed only by a single person. And we should, of course, fix all security bugs leading to privilege escalation to root, which is not as easy as it should be. Okay. So in addition to system security, we also need the examination mode. So how to lock students out of the normal programs and files during the examination session. One is to use a distinct user account, a distinct Linux virtual terminal, and prevent VC switching, a lock user interface so that only a very limited functionality is available. Linux desktop environments are not designed for this. For example, GNOME needs customization. We could use BRAP, for shadowing access to shared directories. And we could also use some mandatory access mechanism. One example is Tomoyo Linux, which is a 15-year-old technology that it appears that almost nobody uses, but it looks promising for this because it can be used to set up a restricted process tree, which is a separate process tree, and a normal process need not be affected. And this is an image from Tomoyo Linux documentation that usually in a normal system, processes, applications can go freely as they like, but we can set up this configuration so that only these roads are permitted, and processes cannot freely start other processes, for example. And Linux kernel is the police that has fences and protects the system. And we also need some actual application. So I see that we should write a custom web browser. For example, in an examination session, users do not need to manage web addresses in any way. So do not give them any web addresses. We should manage the addresses somehow and only provide the features that are needed for the examination. We could also do some surveillance. For example, we could do some real-time exam client monitoring, for example, with Veon. Veon is a free software for classroom management. And we could also spy on user during the examination session, log user keystrokes, take screenshots periodically, and send this to a remote server to catch possible cheaters. These are not nice things to have. And in a system with perfect security, we do not need this. But perfect security is hard to achieve. So the questions in can you trust your computer are relevant here. And one other question is, which is relevant, I think, that if we implement all this, does this violate GPL version 3? My understanding is that this is permitted as long as the computers are owned by schools. If the computers are owned by students, then we have a conflict. So I think schools should have right to manage their systems as they like, but they probably do not need or want to subvert the operating system security in this case. These system requirements are of the upcoming Finnish upper secondary school digital exam application. They are not told us explicitly, and I'm partially guessing here. But the problem is that the competition implements some of these, and because these are explicitly supported, we do need some similar level of system and exam mode security. And if we do not implement all of this, we might have a weakness in the system that can put us into these not to be used in schools category. And currently in Finland, the Puovo OS system that is developed by us is running on maybe about 20% of the Finnish upper secondary school laptops. That is over 10,000 machines. And if we do not react to these changes, we will eventually lose that market to proprietary alternatives unless politics or reality intervenes. And these are work in progress. The good news in this is that with Linux and free software, we can possibly do a better job than the competition. So here's a final word of warning, a word of caution to educators in other countries. Consider the usefulness of written examinations, consider the usefulness of pen and paper, and really the benefits of the digital examinations should be compared against pen and paper. This is one of the hardest questions in computing, when we should use them and when we should not use them. Thank you for listening.